Okay, in this lesson, we are going to treat electricity. So we understand what electricity is all about. So, so let's understand what electric current is. Once we hear electricity, we talk of electrons. Electrons. Hmm? So when these electrons now, when it start flowing, it is now called electricity. So electric current is the rate. So the rate at which this electron goes in a medium is called electric current. So electric current is the rate at which electric charges flow through a conductor. So these electrons only flow on a conductor. So the rate at which it flows, the rate means if this is an electron, for example, the time it takes this electron to move from here to here is what we mean by electric current. Some go faster, some go slower. So that's it. So what we should note about the symbols we need to note about I is for current, Q is for charges, and T is for time. So the SI unit of current, electric current is ampere. So that's it. Then potential difference. Potential difference is the work done in moving one column of charge from one point to another. So if this is a charge now, remember that the current is these electrons, the rate at which it moves on a conductor. If this is a conductor, for example, it's a metal wire. So the rate at which this thing moves, the rate at which it moves is what? Is electric current. So now we want to check the work done. The work done by moving one charge from this point to another is called potential difference. That's what we mean by potential difference. The, then EMF. EMF is the energy supplied by a source to move one coulomb of electricity. So now, these charges, we all know that if this is a battery, it has a little electron charged, right? So the energy it takes to push this thing, remember this electron, the energy it takes to push it from here to here so that we will not have light. So that's how battery works. So for example, if this is your battery, if this is a battery now, and your phone needs electrons to work, is the EMF of this battery that will be pushing the charges from here to here, making it to circulate on this. So that's what the EMF is. EMF means electromotive force, is the energy supplied by a source to move one coulomb of charge around a complete circuit. Yes, the SI unit is voltage. So the difference between EMF and potential difference. So we need to know the difference between EMF and potential difference. Energy supplied by the source than energy used between 2 points. Then this is measured when current is open, while this is measured while current is closed. So the symbol is this. This is also the symbol. So note the differences. Then why this electrons, why this electron is flowing in a conductor, right? Remember the rate at which is flowing is called what? Electric current. The current. Why the energy it takes for this charge to move from here to any place is the EMF. Let's get it right. Why the work done on moving one charge. So the work done on moving one charge is called the potential difference. So that's it. If when we have done work, energy and time, we'll find out that and power rather. We find out that these two look alike, but they are not exactly the same thing. So now what then? Why this thing is moving? There is a resistance, like a friction. Whenever somebody is moving, there is a friction, right? Trying to withstand the flow of electricity in a circuit, in a metallic conductor, or any medium is flowing in. It's called a resistance. So resistance is the opposition offered by a materials to move the electricity. So for example now, if we have a copper wire, it has low what? Resistance. That's why it's the best form of conductor that you can use for electricity. But because it's very expensive, another alternative is aluminum. So this is the AU. Copper is AU. So AU is the copper. So it's a good alternative of what to use wire as a conductor. So what are the factors that affect this resistance? The length of the conductor. The higher the length, the more possible resistor we have. We have the thickness. We have the type of material. For example, if you use a wood now, it will never conduct except you do one or two on it. Then one have what? Temperature. These are the factors that affect a resistor, a resistance. So let's take Ohm's law. Ohm's law says V is equal to IR, provided that the temp at constant temperature, the current flow through a conductor is directly proportional to the what? The difference to the potential difference. So that's it. So the formula we should know about Ohm's law is this. V is equal to IR. So and the SI unit of resistance is ohms. This is the symbol. So electric power. Power is the rate at which electric energy is converted into other forms of energy. That's what we mean by power. The rate at which electric energy is converted to another form of energy. So P is equal to VI. Of course, the SI unit is watts. So, example. Now, an example is that we have a resistor, we have a battery and we have a resistor, right? So we have 20 volts, while we have 10 volts, 10 ohms. So to achieve this now, the question says find the current. Remember that V is equal to IR. according to Ohm's law, right? So taking this, V is 20, R is what? 10. So we now have that V is equal to 20 multiplied by 10. Well, 20 multiplied by 10 is 30. Sorry, is 200. 200 watts. Is 200 okay, sorry. We have V is equals to IR. We already know V and we know this. So our I is equal to V over R. And I is equals to, I should be equals to 20 over 10. So the current is 2 meters. It's 2 ampere. So this is another good worked example. The question says that we should find the power dispensed. Remember that power is equal to, sorry, power is equal to IV. So if we can find I and we can find V, we'll solve this problem. So, and the resistor is V equals to IR. So let's find V now. And V is equal to, voltage is equal to 8 multiplied by 3. 8 multiplied by 3 is 16. It should give us 16. It's 24. So the power now is equals to IV. The current is still 8 multiplied by 24. So now I have that the power is 8 multiplied by 24. Okay, sorry, I made a mistake. I said you have power is equal to IV and V is equal to IR. So if you replace this with this, we now have that P is equals to I multiplied by I multiplied by V. And that's how we have that I is equals to multiplied by R rather. That's how we have that I is equal to square root of I by R. So substituting this now, we now have that current is 3 multiplied by raised power 2 multiplied by 8. And that's how we now get 72 watts. That's the answer. So now let's go to another thing, electric circuit. So an electric circuit is the so electric circuit is the an electric circuit is a complete path through which electric current flows. So if this is electric current now moving and it sees a conductor and it sees another non-conductor, it will definitely follow this path going to another place. So the electric part is this. So we want to organize it. We want to understand it and not get it organized now. So at this point now, you should know the basic component you should be able to find in an electric circuit and the symbols. So open circuit, open and closed circuit. Open. When you talk of open circuit, it means that the circuit is open. That means it is not, it's off. Closed circuit means that it's closed. So that means that is on. That's what you mean by open and closed circuit. Then let's look at the diagram. A circuit. You want to represent a cell or a battery. You represent it with two lines. You want to represent a switch, you represent it with this. You want to represent amp, a current. Current is current. You can represent it with an arrow. A resistor is important. You represent it with this or this. Then the voltage is V. So let's make a simple circuit with a resistor, a capacitor. Can you see that the lines are equal? That's what we mean by capacitor. And the voltage source. So that's it. So please, you need to know how to draw this and label it. Draw an electric circuit and label it. Then all these simple calculations and sources of electricity, of electric current, all this.